Okay, gonna try this one more time. Get my volume correct. This is from my Google Classroom that I used to use in my classroom. I still use it to teach other people now, or even teaching teachers. So this would keep me on track for teaching stuff. So we had been teaching the Titan building block series, and we're also going to incorporate some other stuff coming up for Immerse to Learn. But as I would go, this would kind of keep me on topic. And it would be also, if I was doing Mastercam, same thing. We'd be going through the Titans and stuff like that. We go back to the Fusion side. So we do the 1M, we'll do the 2M, and then we go into teaching how to do logos or engrave your name on the back. Then we'll do the 3M. We'll talk about doing soft draws. The round soft draw is probably the easiest one to make. And also, if you're doing the Autodesk Haas series, we have soft draws incorporated in that also. Then we get Titan 4M, 5M, and we get into blueprints. So I'll probably also rebuild this also to incorporate the Haas Autodesk course and give a. It's laid out in order, but I like adding in some of my own content. We have another one here, creating your own blueprint in your CAD, whether it's Fusion or SolidWorks. Then we have 6M. Then around after the 6M, we get into different metals, steel. And this is kind of when even though I've been kind of teaching feeds and speeds a little bit to begin with, I don't think it's really sinking in. When we get into different metals, it will have them recalculate everything. So we give them a chart, some stuff, and do the back of the CNC mill workbook has got the formulas in it. Or if you had a machinist calculator. Plus, I'll have charts all around the shop, how to calculate it if you don't feel like calculating. You can look up just RPM. We use the Haas machine. It's got a calculator built into it, and it's actually got some SFM and chip load data in there. Some of the milling machines have a calculator on there, or we could do it with your hand calculator, and just have them get into learning how to calculate. So this was my course on, and I'll start with the Mark Terryberry video on how to calculate feeds and speeds. Of course, it's got the tractor, and we talk about the tractor, and I also would use another example of driving down the highway, and you got the Walmart truck next to you, and you're both traveling 70 miles an hour, and I'll say, what is that in feet per minute, surface feet per minute? So you're both going the same feet per minute. Which one is rotating more RPM? So, and then I'll have them say, of course, the little tires rotate faster than the big tires in order to cover the same feet per minute. So that's kind of like, what does feet per minute mean and all that stuff. So we'll do that video training, and whoops, where did I go here? Back down. Here we go. Okay, then I had a playlist here, which actually has some videos that I did. But I got the calculating feeds and speeds. This is an excellent one from a friend of mine that used to work for ISCAR. He had made these videos with this other group, and we call him ISCAR Rick. But his picture isn't on this, but he's in some of the other videos.
Today we will be
and how we're calculating. Of course, they're using like ISCAR tooling with carbide insert tools. But they get a little bit in the depth of cut. It's got some visuals there. It's a pretty good demo. And then I also had, these are my older videos and feeds and speeds, and I thought that I really should update that. But in our feed and speed video, we had a basic chart. There's a chart that I would have in class, and I would hand it out. Oops, where's my little chart? There it is. And we just go down and say what material you got, which SFM is appropriate, like in the middle, chip load, depending on basic size of tool. We'll do that. And we just keep on plodding along, just mostly on the basics, and also kind of thrown in that these older charts are based on half of the tool, or 50% tool load. And now we got into these dynamic or adaptive cutting strategies that you're not stepping over as much, you're actually making a thinner chip. So in order to take advantage of that, we actually need more feed rate. But there's not many very good calculators on how to get, like, how do you calculate 3 thou chip at 20% step over or whatever you're using to calculate that. Some use an engagement angle, some use literally step over or optimal load or whatever they want to call it. So I would start with the basics. I personally think you should build your own course and utilize these topics instead of having an all-in-one course. Every all-in-one course I've seen is almost too deep, too engineer thinking. And not that machinists aren't like engineers, but we want the basics. As long as you get the fundamentals and basics, I think that's the key to everything. I really like the feed and speed topic and tool selection and all kinds of stuff. When I was actually getting more into the tricordial, I guess technically it's not tricordial, but anyway, I think Tim Paul used to be on Autodesk. We used to talk about that a lot. And but what that all means with different cutting strategies versus the old pocket that we used to use for roughing, and now we got the adaptive or dynamic style of roughing out a part, and what that all means. And even when the old days when we did pocket, going to the corners was like a nightmare because you'd end up like fully plowed into the corner and you get a lot of squeaky noises. So anyway, so I would just roll into that. And there's another great series. I'm going to pull that one up and back to my class. So I got my videos, and I also did a playlist on. This is from Helical Tools, and they have one called In the Loop. And this guy here is great, and I love watching his videos. He can talk about chip thinning, SFM, flute count, angles. I just saved a couple of them, but he's got a whole bunch. You could build a whole course just out of him and some charts and calculators. And then you can get more into like how deep are we going, how much sideways are we going, how much engage, how much do we want to bury a tool in there, all that kind of stuff. It's actually really, his stuff is excellent. I mean, it's probably the best I've seen out there on the simplicity level. Of course, they made it so they can sell some tools. If you go into the Haas tooling, let me see if I can pull that up. And if I just go in and I just put in feed and speed, some various charts will show up. But I'm just going to go in, and remember we all get a discount on cutting tools. I'll go end mills. And there's actually, I wish they had stayed open. It actually has some descriptions of what the difference is in there. Well, here they are, series. There they are. What's an HEPM end mill, an HSP one? So there's some various stuff, a lot of reading there. All right, what an end mill corner type is, a number of flutes, end mill videos, control your chips. There's some other one. I think Mark's got some other ones. All right, on sale. So let's go with inch. Let's do something simple here. Cutting diameter, let's pick the old sturdy 1/2 inch. I don't know much about the series, but I'm going to say let's go into categories. We'll go with aluminum, and we'll go carbide. We'll go now we'll leave the coating alone. Square-ended end mills. Forget about length. And notice it's just 3 flutes. Okay. So now we have only 2. HSAM, and they're both HSAM. All right. Probably a difference of length. Yes, it is. All right. If I go into here, in stock, low cost, And right here, technical documents, feeds and speeds. There you go. There's a feed and speed chart. It actually has the funny VC, SFM, all that kind of crazy stuff. It's got basic, it actually has RPM calculations. Of course, you can never use these RPMs because a half-inch end mill in aluminum, they got down here 61,100 RPM. But we also have inch per tooth of 15,000. So that's honking side cutting. So there's some basic charts. I try to find some real simple to understand basic charts. I think these are kind of like the engineering style calculator. I like the more basic one of the one that's actually in the back of the Haas milling workbook is probably the simplest one as far as having the formula. And what else do we have here? So I got actually I like using my classroom because it kind of keeps me on topic of what I'm going to talk about. This is this is kind of a basic feed and speed chart I would hand out to everybody, or I'd have them taped on machines. And I'd have them, let me blow this up a little bit. There we go. Basic materials, not the color-coded ones. A range of SFM and a range of chip load, and what that all means. And have them like randomly, maybe on Tuesdays, you do some feed and speed calculations in the morning. And we'll do something like, I think we call it, I don't know, it's like 5 minutes of busy work while I'm doing attendance. And there's some other talks in here about increasing feed rates depending on coating, and then radial depths of cut, slotting. Like slotting is the toughest thing to do, reduce at 20%. Of course, these are on older techniques, not the high HEM or HSM style of dynamic or adaptive toolpath cuttings. And also, when you get into that chip load factor of the 50%, if you only took 20%, what it actually is the chip load. If you want to get efficient, you say, I want to get 2,000 chip load, and if you actually find some kind of calculator that can recalculate, you're probably only going like 8/10 chip load. And if you can take advantage of it. Of course, a lot of us would wing it and kind of like play with the feed rate and go, that sounds fine to me, and then I change the feed rates. But we need to be a little bit more technical, I think. At least have a range of what's the high, what's the low, start in the middle, and you got like, in case it sounds bad, I can turn it down. Geez, I think it's cutting real nice. Let me crank it up 20%. Sounds great. Let's reprogram it next time with better RPMs, better surface feed. Now, if you're in here's the Titan 1M I pulled up. And when I give them a tool library, now, and I base it on the machines that have the lowest high RPM standard. So we have TM series and we have VF. So the VFs go to 10,000 and the TMs go to 6. So we cap it at 6, especially for the beginners. So in this case, when they go into here, they just pick whatever they're doing, adaptive, pocket, contour. So they pick pocket. Now the RPM 6,000, the chip load's 2,000, so it actually recalculates all this stuff. And there's a little picture of the 50% step over, by the way. And the adaptive area, we actually also have it populate the optimal load. So some of the stuff is like it's hard to explain, so I have it so that it's preset. And then later on, when we get into the, where would you go? Back to cutting steel right here, it's Titan steel. And I'll actually have a video here. And a little bit of, here's one here on the high-speed machining thing that Mark had made. So, upload a new tool library I actually have a tool library for steel, but I'll have them pre-program one of their parts for steel. And also a little bit about tools. Are we changing end mills? Do we need to go to 4 or 5 flute end mills? Do we need to change the tap? Will the tap break in steel? Which means if we're using forming tabs, we got to change the drill type or drill size and what that means. So I think these are like simple things that can make them think about feeds and speeds and tool selection and tool path techniques. What are we going to use? Are we using straight drill? Are we shallow pecking? Are we deep pecking and retracting? Are we using the adaptive style? Do we go? How deep are we going? Are we doing like the old days of pocket, going down a little bit at a time, Because if we went full depth, it probably would clog the end mill. But if we do adaptive, we won't clog it or break the end mill. So these are all good topics. Just my belief that you should kind of build your own course around some good video or data charts. Video and data, really good. And kind of make your own deal out of it. Okay, CNC Dude Ed signing off.